Good morning, 5P. This is Mr. Wong. Today is the 20th of April, Monday. Two parts to this lesson again. First part will be going through homework on Friday, activity 5.3, electrical conductors and insulators, where you make use of the circuit tester to go and test the different materials to see whether they are electrical conductors or electrical insulators. And then, of course, the SIN page, if I'm not wrong, 13 and 14. Okay, and after that, we'll be looking at a closer look at closed circuit, okay, for the second part of the lesson. All right. Okay, so let's start with last week's homework. Okay, let's start with the SIN first. All right, so last Friday the lesson was on electrical conductors and insulators. So I will use red for conductor. I will use blue for, okay, maybe I'll use red for insulators instead, because you know that insulators do not allow electric current to pass through. And I'll use blue color for conductors. Okay, so blue color for conductors. Okay, done. Right, so last Friday we learned about conductors and insulators. So let's see whether we really know about them. So materials that allow electric current to pass through is what we call electrical conductors. Don't just write the word conductor. Conductor can mean conductors of heat, can mean conductors of other things. So make sure you write electrical conductors. Right, so make sure you put the word electrical in front of them. Okay, so materials that allow electric current to flow through are electrical conductors, and those that allow electric current to flow through them easily is what we call good electrical conductors. So the word here is easily. Okay, the word here is easily. So of course, there's different degrees of allowing electric current to pass through. Those that allow it to pass through easily are what we call good electrical conductors. So the word good is in front. Okay, so this is because it allows electric current to flow through them easily. So that's why I put in the word good in front of them. Okay, of course, there are those that are not that good. Okay, all right. So materials that do not allow, so the third one, materials that do not allow, let's use a red color instead, that do not allow electric current to flow through them is what we call electrical insulators. Again, don't just put insulators, make sure you put the word electrical in front of them. Okay, electrical insulators. Okay, so number 4, what are good electrical conductors? Okay, what material are we talking about here? Most metals are good electrical conductors. Basically, all metals are good electrical conductors. Okay, so example of good electrical conductors, the common metals that you have in the wires, for example, copper. You also have gold. Okay, sometimes you see the HDMI cable is gold-plated, the ends are gold-plated. Okay, gold is a good conductor. And also you have your, for example, iron. Iron is also a good conductor. All right. So any metals, basically, any metals you write here, as long as they are metals, they are good conductors. Okay. However, there are also some non-metals that I want to elaborate on. There are some not all non-metals are electrical insulators. Some non-metals are also conductors of electricity. For example, just want to mention just one. For example, you have graphite. Okay, graphite is actually a non-metal, and where can you find graphite? Is in your pencil lead. Okay, pencil lead, and later we'll try using the circuit construction kit to figure out whether can it conduct electricity. Okay, pencil lead. Right. So some non-metals can conduct electricity. For example, graphite. Graphite can conduct electricity. Okay, so where can you find graphite? In pencil lead. Okay, not all metals are solid at room temperature. Some metals are liquid in room temperature. For example, mercury. Okay, mercury is a liquid at room temperature. Okay, So sometimes doesn't mean it must be a solid to conduct electricity. Even if it's a liquid, if it's a metallic liquid, it can conduct electricity. And most electrical conductors are also good conductors of heat. Why is that so? Because as you see, most electrical conductors are metals, and metals we know are good conductors of heat as well. Okay, so that's the answer for page 13. And now we go on to page 14. Now we talk about insulator, and I will use blue. Okay, insulators. Okay, insulators are materials that do not allow electric current to flow through. So it's what we call electrical insulators. Make sure you put the word electrical in front of them. Okay. As we know, metals are good conductors. So on the opposite side, non-metals are good insulators of electricity. Okay, so metals are good conductors of electricity. Non-metals are good insulators, the opposite end. So examples of good insulators like those that cover the wires, things like your plastic. These are the materials. Okay, plastic is a good insulator. Rubber is a good insulator. Sometimes if you look at your ironing board, the iron you use to iron your clothes, you realize that the wires are also wrapped in fabric. Okay, fabric is also a good um, electrical insulator. All right, so plastic, rubber, fabric. So wires, the normal wires you see for a handphone charger, your television, they are usually covered with good uh, electrical insulators such as your plastic and your rubber. Okay, and your rubber. All right, so quite simple. This is what is happening. Okay, and the things around us. Okay, so this is for activity. That is for SIN page 13 and 14. Now we go over to the activity 5.3, electrical conductors and insulators. Okay, which is this one. Okay, I hope you have filled up this part. That's what we have said just now. Things that allow electric current to pass through is what we call electrical conductors. Okay, it doesn't matter it's conductor or conductors, it's fine, but I'll put conductors here. And electrical blank do not allow electric current flow through them. Let's use a different color. Okay, do not allow electric current to flow through them. So this is your electrical insulator. Okay, so conductors allow electrical conductors allow electric current to flow through them. Electrical insulators do not allow electricity or electric current to flow through them. Okay, so this is what you have constructed by right using the online software. I hope you really did it, because from your homework on ClassKit, I don't know whether you are doing it or not, because it's all blank except for some of you. So for those who have done it, thank you very much and you have learned a lot. For those who have not tried, please go and try to use the electric circuit software and try to construct circuit and try to fill in the answers for the experiment that we are asking you to do. Right, so okay, so with this later I'll show you the electric circuit tester. So what we have is all these items, a dollar bill, a paper clip, a coin, eraser, hand and dot. Let's write down our material and write down our prediction first before we go on and see the simulation. Okay, so for dollar bill, in Singapore you realize our dollar bill is made of plastic. Okay, last time it was made of paper, correct, but now it's made of plastic already. So let's put plastic down. Paper clip is made of metal. Then you say, teacher, my paper clip outside got this plastic thing. Okay, let's say if we remove it, because the one that is shown in the simulation, the one is without that plastic covering over it. Okay, so paper clip in this case metal. Coin wise, definitely metal. Eraser, you should know that it's rubber. Sometimes we call eraser rubber also. So eraser is a rubber, made of rubber. Flesh and hand and dog is made of I'll call it flesh. You can call it muscle, you call it cells, I'm fine, but I'm just gonna put flesh over here. Okay, so hand and dog made of flesh. All right. Okay, prediction wise, we know that metals are good electrical conductors while non-metals are good electrical insulators. So in order for the bulb to light up, it must be a conductor. Okay, so in order for the bulb to light up, must be a conductor, which most likely is a metal. Okay, so for this case, plastic, no, it will not light up because it's an insulator. Metal, yes, it's a conductor, so it should light up. And then once again, coin, which is a metal, yes. And then after that, rubber is no, because rubber is not an electrical conductor. And then both flash is no, because flash is definitely not an electrical conductor. So basically it's only the metals here, which is your paperclip and your coin. Okay, so now with that, this is our prediction. Now we're going to try from the dollar bill to the paperclip and so on and so forth. I also want to show you pencil, okay, and how we connect a pencil, that sometimes it works, sometimes it doesn't work. Okay, so let's go over to the circuit tester. So this is exactly the circuit tester on page 36. Okay, so what I have here, I'm going to start off with a pen, pencil. Okay, so you realize that in your book it says no, the bulb will not light up. Why? Because they are actually connecting to the wooden part of it, and that's why the material they say is wood. Okay, so in the example given, it is connected to the wood part of the pencil, and you realize when as I connect, the bulb doesn't light up. However, if I connect it to the pencil lead, which just now during SIN I said that it's made out of graphite, which is a non-metal, but it can conduct electricity. So if I connect it to the lead, you realize that it will cause the light bulb to shine. Of course, it is not a very good conductor of electricity. That's why you don't see it shine very brightly, but it is still no doubt a electrical conductor. That's why the bulb light up. So for if I connect to the pencil lead, which is made of graphite, it can conduct electricity. It will be a closed circuit. But however, if it's connected to the wooden part of it, it is a insulator of electricity. It will not conduct electricity. So it will be an open circuit. Okay, so this is the example, so I will not talk too much over here. Okay, now we move on to the next one, which is the dollar bill. So let's get the dollar bill out. Okay, let's connect and connect. The bulb light up? No. So dollar bill, plastic, electrical insulator, do not allow electricity to pass through. Light bulb does not light up. Okay, so this is no. Okay, paper clip, let's try. Okay, paper clip. Okay, over here, connect to paper clip, and you realize the light bulb lights up. Paperclip, metal, electrical conductor, means electric current can flow through, light bulb will light up. Okay, so for paperclip, answer is yes. Okay, let's try for coin. Okay, coin, up over here, connect to the coin, connect to the coin. You see that the bulb lights up. Why? Coin is a metal is an electrical conductor, conducts electric current, light bulb lights up. Okay, so coin, yes, it will light up. Okay, next one, eraser. Okay, eraser, connect to the eraser, connect to the eraser. Nope, doesn't light up. Why? Eraser is made from rubber. Rubber is an electrical insulator. Do not allow electricity to pass through it. So light bulb will not light up. Therefore, answer to this one is no. Alright, so next one, hand. Okay, so let's grab the hand out. Let's throw this away. So hand, connect to the hand, connect to the hand. Doesn't light up. Why? Flash is a non is not is an insulator of electricity, doesn't allow electric current to pass through, will not light up the bulb. So, and you realize that this is the same for dog, because dog also flash. So connect to the dog, to the flash, you realize the light bulb doesn't light up. So same idea, dog made of flash is an insulator of electricity, do not allow electric current pass through, will not light up the bulb. Okay, so it's the same for hen and dog. Both are also no, do not light up the bulb. Right, so this is the result, and it is the same as what we predicted based on electrical conductor and electrical insulator. Okay, so over here, some of you tried, but some of you mistaken objects versus materials. These are your objects, is under object. These are your material. So if you write, for example, electrical conductor is paperclip and coin, it's wrong. Paperclip and coin are your objects. I want material. I want material. I want material. So what materials are electrical conductor? There's only one over here, metal. Of course, you can put steel or gold coin, whatever. Yeah, gold, for example, can. But the material is metal. So on the other hand, which one are insulators? You have your plastic, you have your wood, which is your pencil, you have your rubber, and you have your flesh. And basically, these are your non-metals. Okay, so we are talking about materials here. So don't talk about objects. Okay, we're talking about materials here. Right, so this is the answer for the last part. So this is the end for the going through part. The second part of the lesson will be, we'll be looking deeper into closed circuit. All right, so see you in the next video.